Hi guys, David here from Scientific Reactions. So I've been seeing this paper everywhere this week. I saw it on TV, and apparently according to a Google search, it is on every possible news outlet. And basically the idea is that babies in the womb will smile if their mothers eat something that kind of has like a sweet flavor profile, and they'll grimace or make a crying face if they eat something that has a bitter flavor profile like kale. So it kind of set off my BS alarm a little bit. You know, whenever I see something like this that's almost like made for TV, it just makes me wonder, what is the actual method and can they actually count on these results? So to do this, I wanted to see if I could actually track down the original paper, and I did. It's called Flavor Sensing in Utero and Emerging Discriminative Behaviors in the Human Fetus. And it was first published online September 21st, 2022, which is just a couple of days ago at this point. So after looking through the paper, one of the first things that jumped out to me, which is really one of the causes I had for doubt, is this idea of to what extent can flavors actually be transmitted from a mother to an unborn baby. And so apparently there's actually some literature backing to this. So it does say previous studies have sensorially monitored changes in flavor quality and intensity of the amniotic fluid after the ingestion of odorants or tastings by mammalian females. Of course, that's 1985 research and 1995 research. So I guess there's at least some connection, and that's been pretty well established, that the flavor and odor profile of the amniotic fluid that the baby is kind of swimming in is going to change depending on what the baby's mother is eating at that time. That got me thinking of kind of like some of the extreme examples, like if the mother was to eat a ton of garlic, and I have to imagine that it would be like, for the baby, it would be like swimming in a garlic soup. And I know that they can also swallow, like drink the amniotic fluid, so it would be like swimming through garlic soup and occasionally taking a gulp, which does not really sound that appealing, but I guess there's nothing they can really do about it. So the second thing that caused me to doubt when I originally saw this on TV was I just had to wonder about the statistics of it. Like, did they maybe take some pictures, using ultrasound of the baby smiling after, the mother ate some carrots, and then they were like, aha, see? Or was there some statistical significance to this? So it looks like they recruited a total of 100 mothers, and there was some attrition throughout the study. So, partially because of COVID-19, apparently, like not everybody was able to make their appointments. But basically, by the time they were actually doing measurements, and they took measurements at 32 weeks and 36 weeks of gestation, they had 26 mothers who they got measurements at both time points for, who were the Kale flavor group, 25 for the carrot flavor group, and 30 for the control group. So that's not bad. So the basic idea in terms of how they were going to carry it out is that the mothers would not eat anything at least an hour before the study started, and then at each appointment they would take a flavor pill that would either have a bunch of kale in it or a bunch of carrot essence in it. And the flavor packet, or the pills rather, were designed so that they wouldn't break down in the stomach, so they would survive until they got to the small intestine. And the reason for that is they didn't want basically the flavor to get distributed or broken down before it reached the part of the body that's actually going to absorb the nutrients and then be able to pass them on to the amniotic fluid. And so basically about an hour before the scan, they would take their pills or not take their pills, as the case would be. And then they took a look at the babies, they recorded them on 4D ultrasound for around 25 minutes. So a quick word about what 4D ultrasound is. So I found this video, I'll link it below, but it's basically a little tutorial on what the different types are. This is 2D ultrasound. And then there's 3D ultrasound, which is where I guess they take, no, that's 4D, sorry. Here's 3D. They can actually take a three-dimensional picture, and then they can rotate it, but it's still a still picture. And then 4D is this, and I don't know how they do it, but they can actually have, they can see the baby moving. And so at this point you can see the baby's face. It's sticking its tongue out. Oh, that's cute. What's it doing? All right, this is not from this study, but this is just a tutorial on what 4D ultrasound is. But you can see they've got a really good picture of the baby's face. And so at this point, you can see how they could start to actually determine maybe emotions, or at least look at the, what sort of musculature things the baby's doing with their face. Okay, so that's 4D ultrasound. So now we know how they're going to be looking at the babies, but the other question is, how do you define, especially how do you define in a statistical way, what's going on? Because I could see this, like you could look at a baby's face, or you could look at anybody's face, and if the sound was off and if the resolution was low, I feel like you could mistake someone who could have been crying. You could mistake them for laughing, or vice versa. But what they choose to do is they actually took like a really detailed analysis of the fetal facial movements, or the FMs, and at least these ones I think they called out because all of these ones seem to either correlate with a laughter face or a cry face, and they have this word gestalt. So I had to look it up, but a gestalt is apparently an organized whole that is perceived as more than the sum of its parts. So I guess that means when they say a laughter face gestalt or a cry face gestalt, that really just means that all of these things, all of these facial movements correspond to like the overall effect of a laughing face or a crying face. And so they have, they're kind of funny. They're called the inner brow raiser. So I'm looking at my face, sorry, just like inner brow, like maybe like that, and then the brow lower is like lowering your brows. That makes sense. A cheek raiser, I guess. Nose wrinkle. Okay, so I probably shouldn't try to do all of these movements, and you probably don't want to watch just a grown man trying to figure out how to do a nose wrinkle. But I guess all of these things put together, there's a certain profile for a laughing face and a crying face. And at that point, I think what they're doing is taking the different images and checking out the combinations. So this is baseline. So here on the left, A here is a neutral face, and then B is a cry face gestalt. And you can tell this partially because it has an FM11 and an FM16, so it has a nasolabial furrow and then a lower lip depressor. I guess that's a pouty face, really, a pouty lip. And then here's a laughter face gestalt, and that's a baseline on the left, so that's a neutral face. And then B is a laughter face, and it has FM6, which is a cheek raiser, and it has FM12, which is a lip corner pull. So yeah, you raise your cheeks and you pull the corners of your lips, and that becomes, I guess that's a laughter face gestalt. So at that point, what they were able to do is actually do statistical analysis of the relative frequency of different fetal movements for the different groups. So this you can see, figure 3 is you see for the Kale group, the carrot group, and the control group. And you definitely see some pretty profound differences. In particular, they're calling out the FM10, 12, 16, 20, and 24 as pertaining especially to these things. And you can see the FM12, the lip corner polar for the carrot group, the exposure group, that was the group that was exposed to carrots. You can see has hugely more lip corner polars versus the control, and way more than the Kale group. So basically, when the babies were exposed to Kale, they were not doing the lip corner polar, which apparently is one of the strongest facial movements associated with the laughter face gestalt. So the babies, I guess, were kind of laughing when they got carrots, and they were definitely not laughing when they got Kale. And then FM20 is the strongest one for the Kale group. That's the lip stretch. So I don't think they have a picture of the lip stretch, but I guess we can imagine it's probably something, maybe it's a little bit like lower lip depressor, but maybe they're stretching the lips this way and down. And then putting it all together, they were then able to kind of translate the facial movements to the facial gestalts. So remember, the gestalt is like the overall perspective. And you can see there's the Kale group, and then the carrot group, and the control group. And then they have the laughter face gestalt at 32 weeks and 36 weeks for each one. And you can see basically, so these two groups, this is the cry face for 32 and 36. And basically there was a lot more crying face going on with Kale. There was a lot more laughter face going on for the carrot group. So I actually think overall it's pretty good. You can see also the error bars are pretty significant. There's definitely a fair amount of crossover between some of the bars, but really you can see if you especially look at the laughter face gestalts for the Kale group and compare that directly to the laughter face gestalts for the carrot group, there really is a pretty big difference. Same thing with the controls. And then you look at the cry face gestalt for the Kale group, it really is significantly greater in intensity than that for the, or rather greater in frequency than that for the carrot group. So overall, I would say I buy this. I believe this research. It looks like unborn babies will actually, react, I guess, emotionally to what the mother is eating. And they don't like kale, and they do like carrots. So that's good to know. Well, thanks so much for watching. If you enjoyed the video, please go ahead and like, and I hope you'll join me again in the future soon. Bye.